Further Solutions Academy. Welcome to Further Solutions Academy. Further Solutions Academy. Encourage us more, help us to share our video and also subscribe to our channel. Help us to share, and if you have not subscribed before, press on your subscribe button and do that for you to get updates of our videos. In this platform, you can learn any topic as far as mathematics is involved and also that part of subjects, physics, chemistry. But presently, we have all what you need on mathematics for you to survive or for you to get it right. Okay, this top video I want to be working on useful integrals in Fourier series. Now, it means I'm already on Fourier series. Now, we'll be talking about Fourier series at this point. Now, when we talk about Fourier series, why are we talking about integration? Because integration is very important at this period of mathematics, which is called Fourier series. Now, most all what we do on integration is, on Fourier series is all about periods. We are talking about moving objects. When the movement is taking place, like for instance, when you have a movement this way, now this is the movement. Now it can move like this. Now this is a period. It means first period first, second period, third period, now, and so on, first period, now, and so on and so forth. Now, depend on the number of periods. Now, when we talk about periods, when you hear a word periods, it means we are talking about what? Integration. And what we most use, what we normally use mostly when it comes to period series, because the movement is always in this form. Movement of zigzag axis. Moving on the axis, it means there will be upper and there will be what? Lower. Now, upper limit and lower limit, it means this is the upper and this is the lower. Now, since that is taking place, it means at this point is lower, this is what? At upper limit. Now, it means integration has come to play already, which is I'll be having what? L, and I'll be having what? U. Now, this movement is always on trig. This is how trig behave. Now, there are four types of trig ratio. We have sine, we have cosine, and we have tan. Now, for this is always on tan. Now, it means the movement is already on what? Tan of the function of x. Now, it means this is a function of what? X. When you plot any graph on sine, you have it this way. It will always move this way. Now, we are now applying it when it comes to Fourier series. That's what I'm working on Fourier series. When it is my cos function, it also be like this. It also be like this. Now, it means I have my upper limit and have my lower limit. Now, that is what Fourier series is talking about. That's what we are talking about in Fourier series. Now, we'll be talking about first period. This is the first period. Now, this is the period 1, period 2, period 3, period 4, and so on and so forth. Depends on that movement you are working on. That's what we are to work on. It means I want to show the usefulness of integration in Fourier series. Now, let me try to do one or two things here at this point in the junction. Okay. You can go and read your books and Now, when we are talking about Fourier series, number one, you have to understand that it's a trigonometrical series. It's a trigonometrical series. And also, the function is what? It will discontinue. It will stop at a point. When you stop, when you hold your machine, when you start moving, and at the point, it must be off. Now, that is what I mean by upper and what? Lower. It means it must start somewhere and head somewhere. That is what I'm trying to. It means it must be what? Finite series. And at this point, you must understand what is called Maclaurin series and Taylor series. They are very important part of, you have to know how series is being generated, how to generate your series. I'm not here to teach series, but series is always like this. It's always like this. Series is always like this, and I think We have done the AP and GP and LOT. Just move on to that, you understand. I'm just trying to show one or two things on series. Now, because series is very important here, because there's no way you talk about Fourier series that we won't understand what is called Maclaurin's and Taylor series. Okay, now before we move on, it's always like this. Let me quickly show how it always look like. Now, my integral of C, let me use C as C, and to this. Now I have sine of what? N pi of x, pi of x all over C, and sine of C with respect of C. Now this one is always like this. When my 0 n is not equals to, it means it not be C when my n equals to k. That's one. Please take note of this one. This also, we have integral of minus c to c cos of n pi x all over c, and cos of k n pi all over c dx. Now also the movement is just like we're moving a function this form, which is my 0 n is not equals to, and also c when my n equals to k equals to n and equals to a series 1, 2, and so on and so forth. And this also 2c when my k is equals to n equals to 0. Now that is what we have to work on. That is why I need to show this, and this video is concerned. That's what I want to work on. By so doing this, you understand. It means when my n equals to k, I will have 0. When my n is not, when my n is not equals to k, I've told you that if it's not equals to k on one of our limits form, it may be greater or less, but I'll try that. And when my n is equals to, when my n equals to k, I will have a constant c. That is what I'm always, which is when it's cost function. When I have it this way, it means the first thing is when my n is not equals to k, I will have this. And when my n equals to k equals to a series, it means a series 1, 2, 3, 4. Sequence 1, 2, 3, 4, and so on. Now I will have this. And when my n equals to k equals to 0, I will have this. Now that's what I want to work on here, as far as this video is concerned. Now let me start with the one of upper, which is trig. Let me try to work on trig part of it. Sine part of it. Okay. I have to be, because this body I have to manage it, because to take a lot of. Okay, if I have this type of problem, I want to show this. Show that integral minus c sine n pi x all over c sine k pi c all over c. This is x. The x which is integral round, which is 0 when my n equals to k, and when my n when my n is not equals to, when my n is equals to k. The first one, when my n is not equals to k. Now let's work solution. Before I solve this part problem, you must understand the logic behind trigonometry. Very, very important. We all know what trig is saying, which is a sum of trig. When I have sine a plus b, I will have it as sine a, and I also have it as sine a cos a, sine a cos b plus sine, cos a sine b. Now, if I have it, call it equation 1. Now, if I have it also sine a minus b, I will have it as sine a cos b minus Now, if I have it, call it equation 2. Now, if I have it cos A plus, the same thing is I'll be having cos A cos B minus sine A sine B. Call it equation 3. Now, and also if I have it this way, cos A minus B, the same thing as cos A cos B plus sine A sine B. Now, equation 4. Now, that is, you have to understand from our elementary mathematics. Since we know this, now what we need to do is that, what can I do next? Now, from here, just say let my z, which is my z, equals to pi x all over what? All over c. Now, it means my dz, it will be equals to x all over c dx. Now, I'm differentiating with respect of x. I'm differentiating with respect of x, which is, I will have that. Since I have that, it means my dz, that my dx, it will be equals to c all over pi dz. Now, it means I'm trying to substitute something here with our normal integration. Now, with what, when my x equals to c, therefore my z will be equals to pi. And when my x equals to minus c, it means my z, it will be equals to minus pi. Now, what am I trying to generate? I'm trying to generate my what? My limit, because at this point, I'm not moving on x anymore. I'm not moving on x. I'm now moving on what? On z. I'm moving on z, not on y. I mean, not on x anymore. It means I must do what is called integral by substitution. I must do what is called integral by substitution. Since I have that, what next can I do? I think everything I need is now available. Now, I can now continue by having, okay, what next? I can now continue by having my integral. It's run from minus infinity, pi to what? To pi. Because this should be. Now, when we talk about pi, this time around, we are talking about what? Degree. We are talking about pi in terms of what? Degree. 1 pi equals to 180 degrees. Please take note of that. Now, when it's minus pi, it means I will be talking about 1 minus 180. Now, when it's 2 pi, it means I will be talking about 360, which is the same thing as what? 1 revolution. Please take note of that information. They are very, very important that we need to understand. Very. Now, it means my pi is on degree. Since my pi is on degree, I cannot continue. I've done the necessary things which I need to do. I can now say that what? My sine, what next? I will be having nz and sine kz and also d. Now, I'm working on the z. Now, my s, the s is equals to this. I'll be having c all over pi dz. Now, which means this is a constant. It's a constant that is only the x. Z is the variable at this point. It means I can write it as well as, I can say that what? Which can also be equals to c all over pi integral from minus pi to pi. Yes, sine n z and z. Now, with this, I'm good to go. With this, I'm good to go. What next can I do? Now, at this point, there's no way to integrate this rubbish. This thing, I can't integrate it at this point. Now, I have to do something that will enable me to integrate without no stress. It means I must run towards my, what is called, what I'm having here. Now, what can it give me this? What can it give me this? It means if I add up, okay, let me just move on to equation 4 minus equation 3. I think I can have something good. Since I have this, it means I'm doing something like this. This minus this, I will surely have what is there. Which means this place will cancel out, left with this. Now, which I'll be having without no stress, I'll be having sine A sine B equals to it will be equals to, what can I have here? This one, there will be what next? It will be, okay, this one will be cos. This one will be 2 of them, because it will be 2 of this, because it will increase, which I'll be having cos A plus B, and what's going to be minus sine minus cos A minus B. Okay, which is this one will be minus, sorry, this one will be plus. What am I doing? I'm adding these two together. Because just what I'm just doing there. Since I have that, and I'll be having sine A sine B, which is equals to 1 all over everything that is here, cos A minus B minus cos B minus A plus B. Now, since I have it this way, I think I can continue with this. It means what I'm having here is the same thing as A. It means what A equals to this, B equals to this. That's what I'm trying to say. I can now continue by having such, which is I'll be having, it means my sine pi, the integral of minus pi to pi sine nz sine kz dz, it will be equals to, now everything that I'm having here, it means I can present it that way, which I'll be having, it will be equals to 1 all over 2 dot c all over pi integral of cos. Now I can now move on to my cos, which is I'll be having cos n minus k, and cos, now n minus k, which also I'll be having minus kz, and cos n plus k bracket of z. Now we are upping. Okay, now since I have it that way, which is everything will be bracket close with respect of z. Now it means I've successfully done what I need to do, which I can now continue. I'll still need this, therefore I won't drop it up. Now I can now continue by having I can now integrate. If I should integrate, with the help of my integration, if you want to know more about integration, go and watch our previous video on integration, which I don't need to stress myself, which I'll be with what I'm having here. I'll be having c all over 2 pi. Now c all over 2 pi. Now if I integrate this point, I will integrate. I'll be having with sine n minus k x divided by n minus k, and also I'll be having minus sine. Yes, sine will come off. Yes, sine. Yes, when I do yes, I'll be having sine. Now I'll be having sine n plus k z divided by n minus k plus k, all close bracket, with respect of, we are moving on pi to minus pi, which is pi to minus pi. Now that is the limit. Since I have that, I can now move on by having the upper limit minus lower limit, which is my upper limit, this 2 pi. Now upper limit minus lower limit, if you can do it, you know that when I'm having sine 0 is always equals to 0, cos 0 is always equals to 1. Please take note of that information. We are talking about periods. Now at this point, I can now say that what I'll be having bracket of 0 minus 0. Now minus the second one will now be what? 0 minus 0. Now which is close bracket. Now everything is 0, 0, 0, and everything will be equal to 0. It means this place has been done. That has been done without no stress. It means it's equals to 0. When my n is not equals to k. When my n is not equals to k. Now, the next one is when n equals to k. When n equals to k. This is when my n is not equals to k, which is this first one. Now, when my n is not equals to k, my n is not equals to k, I have my n is not equals to k, I have this. Now, when my n equals to k, let's see, maybe I will have my constant c. Let's see, maybe it will come up as constant c. Okay, there's no time. I have to be very fast. Okay, now when my n is not equals to k, we have done that. Now, when my n is equals to k, what can we do? When my n equals to k, it means I'll be having sine square. Please think of this x plus sine square. X equals to sine cos equals to 1. Please take note of that. And also cos square x minus sine square x equals to cos 2x. Now also sine square x equals to 1 all over 1 minus cos 2x. Please take note of this information. They are very, very important that we have to use. Now, when my n equals to k, when my n equals to k, please take note of that. It means I'll be working on this part. Now, I'll be having double angle. I will be having double angle. It means I'll be working on double angle when my n equals to n. It means double angle will be. Now, I will now be working on my c all over 2 pi. Please, if you don't know double angle at this point, it will be a big problem, but just understand what I mean by double angle. This is double angle. This is type of example of double angle. It means I'll be having 1 over integral from pi minus. Now I'll be having 1 minus cos 2 minus 2 cos 2. I will be having minus 2nz close bracket of what with respect of the heads, the z. It means I'm just working on double angle. Double angle. It means I have double angles. Okay, since I have that, I can now continue by having, if I should integrate this, I will have the same thing, c all over 2 pi. Now, integrate this one, I'll be having minus, which is I'll be having z, I'll be having z, I'll be having minus sine 2z, 2nz, all over 2nz all over 2n, close the bracket of pi minus. Now, it means I'm just integrating. Now, since I integrate finish there, I can now do my upper limit and my lower limit. My upper limit and lower limit, which is, I have c all over 2 pi, I have z of pi minus pi minus sine 2 pi, 2n z all over 2n pi with, which is that. Now, since I have that, I can now have c all over 2 pi, which is into, I have pi minus pi, which is going to be plus pi. Now, plus pi. Now, this also I'll be having, normally when it's sine 180 is always 0. It means I'll be having 0 minus 0, which is I have nothing to do with it, which is I have sine pi with bracket of 2 pi with 2 pi, which is this one becomes 0. This will cancel this, which is equals to c. Can you see that when my n is not equals to c, when my n is not equals to c, it produces what? C. That is what I'm trying to work on. Now, okay, let me try to do the last part of it, which is the one of cos. The one of cos. Okay. Okay, now, if I'm talking about cos, it means I'm running towards something like this. Integral run from minus c, we have cos n pi x divided by c cos k n x all over c dx. Now there are three conditions there. The first one is when my is 0, we have c and we have 2c. This one is when my n is not equals to k, and this one is when my k equals to n, and the last one is when my n equals to k equals to 0. Now that is what I'm trying to work on. I have to be very fast at this point. Now, with what we have done equation 1 with, we have done that earlier, equation 4 minus equation 3, I think we have done that earlier. You have to stop. We have what is called cos A cos B equals to 1 over 2 integral of cos A minus B plus B, and cos A, yes. Now, okay, I don't know, let me just take, I want to choose something. I think I'm making a mistake. I'm having equation 1 and equation 2, which I'll be having cos A plus B. It will be plus cos A minus B, which is also equals to 2 cos A cos B. That is what I mean there, which I can have cos A cos B, it will be half of what is here, which is a half of integral, bracket of A plus B, and plus cos A minus B. Now that is what I'm trying to say. Now with help of this, let z equals to n pi x all over c. It means my dz will be equals to n pi all over c, which is this z, the x, which is my dx. It will be equals to c all over n pi dz. Now, I think what we have done all this, when you do your integration and you continue with it, you'll be having pi of pi and c all over pi dot 1 all over 2. That means multiplication, which is also I'll be having cos n minus plus pi at the point of substitution z, and plus cos n minus k z, and everything will be on integral of that. Now I think yes, integral of that. Now with this, I'm good to go. When you do it, you will surely say that what, when you integrate this and you do your limit, after you limit, you do all necessary things, you will notice that what you are having equals to 0. It will be equals to 0, which I'm not done it finished, but when you do your integration here and you do the necessary things, you notice that it equals to 0. It means when my n is not equals to k. And the next one is when my n is not equals to k. We have done that. Now, when my n equals to k, when my n equals to k, when you start running your integration, you will be having something like double angle, which is cos squared n k, cos n squared k, to be equals to 1 all over 1 minus, 1 plus cos 2 n k z, 2 n k yes, 2 n k z. Yes. Now, when you do your substitution, when you substitute your function and you do the necessary things, you'll be notice that you have a c all over 2 pi, and you have integral run from pi to infinity. To pi to minus pi to pi, which is you'll be working on 1 plus cos 2 n k z the what? The z all into bracket. Now, when you do all this, you will notice that By so doing this, you have something very good for yourself. After you integrate, you'll be having 2 pi dot 2 pi, which is, this will cancel because one will give us 0, and also you have something like this, which is equals to c, which is when is equals to c. And the last part of it, okay, please, I've got a lot of steps, but you have to understand what I'm trying to say here. What I'm trying to say is integration is the logic behind it. Now, when my n equals to k equals to 0, it means I will be having the same thing how you come up that time, which I'll be having c all over 2 pi integral from minus pi to pi, and cos 0 plus cos 0. 0 can dominate everything. Now, since it's only with respect of what is z, which I will have 2 all over 2 pi integral of minus pi pi, which is I'll be having 2, because I know cos 0 is always equals to 1. 1 plus 1 equals to 2. With this, I will have something like c all over 2 pi with 2 close bracket of pi plus pi, which I will have yes, pi plus pi, okay, which I will be having this, which is this will be having 2 pi and 2 pi, which is I'll be having c all over 2 pi dot 2. Yes, now 2 pi. 2 pi. I might just 4 now. Yes, 2, which is going to be 4 pi. Now here 2. Now, which is I'm having 2x. That is what everything is just like application of integration. With this, make sure you study your integration very well. Why am I so fast? Because of my integration knowledge. Now, once again, further solutions academy. Encourage us more, help us to share our video, and also subscribe to it. Thanks for watching.